Good day, students. Welcome to another video lesson entitled The Angles of Elevation and Angles of Depression. The objective of our lesson is to distinguish between angles of elevation and angles of depression. Next, to illustrate angles of elevation and angles of depression based on the given situation. And then lastly, to solve real-life problems that involve angles of elevation and angles of depression. To start, let us review the prerequisite lesson to our topic, which is trigonometric ratios. In a given right triangle ABC with a right angle at C, if BC is equal to 7 units, angle B is equal to 51 degrees. Let us find the measurement of AC. If angle B is our reference angle, then the opposite side is AC, and BC is our adjacent. With this information, our trigonometric ratios, represented by mnemonic word SOHCAHTOA, that is TOA, which means tangent is equal to opposite over adjacent. Now, let us solve for the measurement of AC, represented by X. So that is tangent 51 degrees is equal to X over 7. To solve for this, let us use the cross product. So that is equal to X is equal to 7 times tangent 51 degrees. Using your calculator, the value of X is equal to 8.64. Therefore, AC is equal to 8.64 units. Next, given a right triangle ABC with the right angle at C, if BC this time is equal to 10 units and then angle A is 25 degrees, let us find the measurement of AB. If angle A is our reference angle, then BC is the opposite side and then AB is the hypotenuse. With this information, our ratio is opposite over hypotenuse. In the main trigonometric ratios presented by mnemonic word SOHCAHTOA, that is SO, which means sine is equal to the ratio of opposite over hypotenuse. Now, let us have now the equation that is sine 25 degrees is equal to 10 over X. By cross product, this equation will become X times sine 25 degrees is equal to 10. Let us eliminate sine 25 degrees by dividing both sides by sine 25 degrees. X sine 25 degrees divided by sine 25 degrees, that is equal to X is equal to 10 over sine 25 degrees. Using our calculator, the value of 10 over sine 25 degrees is equal to 23.66. Therefore, the measurement of AB is equal to 23.66 units. Last item for our review. Given a right triangle ABC with the right angle at C, if AC is equal to 12 units, angle A is 20 degrees, find AB. If angle A is our reference angle, then AC is the adjacent side and then AB is the hypotenuse. With this information, our ratio is adjacent over hypotenuse. In the main trigonometric ratios presented by mnemonic word SOHCAHTOA, that is K, which means cosine is equal to the ratio of adjacent over hypotenuse. Now, let us form our equation. That is cosine 20 degrees is equal to 12 over X. By cross product, this equation will become X times cosine 20 degrees is equal to 12. To eliminate cosine 20 degrees, let us divide both sides of the equation by cosine 20 degrees. X cosine 20 degrees divided by cosine 20 degrees is equal to X is equal to 12 over cosine 20 degrees. Using our calculator, the value of 12 over cosine 20 degrees is equal to 12.77. Therefore, AB is equal to 12.77 units. Now, let's proceed to our main lesson, which is the angles of elevation and angles of depression. The angles of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer's eye, which is so-called the line of sight. If the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called the angles of depression. To illustrate the two angles, let us use the following situation. First, there is a girl. The line from her eye level is the horizontal line of sight. If she moves her eye above to see the object, which is the bird, the line from her eyes now to the bird is the line of sight to the object. And then, the angle formed from the horizontal line of sight to the line of sight to the object is the angle of elevation. Next, there is a building. There is a woman on top of it. The line from her eye level is the horizontal line of sight. If she moves her eye to see the object down the building, which is the car, the line from her eyes now to the object is the line of sight to the object. And then the angle formed from the horizontal line of sight to the line of sight to the object is the angle of depression. To continue, let us answer the following illustrative examples. Given the figures below, let us identify if the angles formed represents the angle of elevation and or angle of depression. Let us have the first figure. What do you think? Very good, that is an angle of elevation. And the angle formed is angle CAT. Next, another figure. Very good, that is also an angle of elevation. And the angle formed is angle BOY. What about this figure? What do you think? Very good, that is an angle of depression. And the angle formed is angle APL. What about this figure? Very good, that is an angle of elevation. And the angle formed is angle BID. How about this last figure? Correct, that is an angle of depression. And the angle formed is angle CAN. Now let us use the concept to the real world. Mark is flying a kite and realizes that 300 feet of string are out. The angle of elevation of the string from the ground to the kite is 42 degrees. How high is Mark's kite above the ground? To answer this, let us use the following steps. First, let us draw the diagram. Mark's flying a kite. It will form a right triangle. The angle of elevation is 42 degrees. The length of the string used is 300 feet. And we're looking for the height of the kite from the ground. Next, we need to have our working equation. From the given information, in which 42 degrees is our reference angle, H is the opposite side, and then 300 is the hypotenuse. So that is sine 42 degrees is equal to H over 300. Now, let us solve. Sine 42 degrees is equal to H over 300. By cross product, this equation will become H is equal to 300 times sine 42 degrees. In our calculator, the value of 300 times sine 42 degrees is equal to 200.74 feet. So our final answer is, therefore, the kite's height above the ground is 200.74 feet. There are 7 other applications to the real world. From the top of the tower with 50 meters height, a man is observing the base of the tree at an angle of depression measuring 34 degrees. What is the distance of the tree from the base of the tower? Show your answer to the nearest meter. To answer this, let us use the 4 steps. The first one is draw the diagram. There is a tower, a man on top of the tower, a tree below the tower. It will form a right triangle. The height of the tower is 50 meters. This tower is parallel to one of the legs of a right triangle on the other side. So that is 50 meters. The angle of depression is 34 degrees. And we're looking for the distance of the tree to the base of the tower. Since this measurement is parallel to one of the other legs of the right triangle, so we can use the other legs of the right triangle to indicate the distance of the tree from the base of the tower, and it will represent D as the measurement. Then we have the working equation. Based on the situation, with 34 degrees as our reference angle, 50 meter is the opposite side, and then D is the adjacent side. So that is tangent 34 degrees is equal to 50 over D. Then let us solve. By cross product, our equation will become D times 34 degrees is equal to 50. Dividing both sides of the equation by tangent 34 degrees, D tangent 34 degrees divide by tangent 34 degrees, it will become D equals 50 over tangent 34 degrees. The value of 50 over tangent 34 degrees in a calculator is equal to 74.13 meters. Then our final answer, since based on the question, we need to present our answer to the nearest meter, therefore, the tree is 74 meters from the base of the tower. Okay, I hope you learned something. Thank you for watching.